All right, today we got characteristics of function graphs, just some very important words and things you need to know about different parts of graphs and what we call. There's a weird looking graph here. We're going to use this on every slide, so I might as well get used to looking at it. The first two words you need to know are what are positive and negative parts of graphs. And basically the positive parts of graphs are the parts of the graphs where it's above the x-axis. That's positive, that part right there is positive. That's positive, that's positive. So if it asks you what are the positive parts of the graph, or where's the graph positive, you would say, well, it's positive between 1 and 3. Notice I'm using the x-coordinates. It's also positive between 5 and 7. And it's also positive between 9 and 11. And that's how you'd write those. All right, that's where it's positive. Now, obviously then, where is it negative? Well, it's going to be negative where it's below the axis. So all that area in there. So, and still, we're going to use the x's. So when I say negative, I'm going to say, well, it's negative between 0 and 1. It's negative between 3 and 5. 3 and 5. And it's also negative between 7 and 9. I don't know why I put a parentheses right there. Remember, the brackets mean it includes those numbers. Actually, I kind of goofed that up. Those should all be parentheses because it's not positive or negative on those numbers. It's actually a 0. You know, wherever it crosses the x-axis, it's called a 0. That number right there is a 0, a 0, a 0. It's not positive or negative. You can't see what I'm drawing. Those points right there are not positive or negative. They're zeros. Okay, it's going to say where is it increasing or decreasing. And these, when you do the increasing, decreasing, increasing means where's it going uphill, decreasing, where's it going downhill. And you got to look at it this way. You always look at it from left to right, and you use the x's. Always use the x's. So if it says increasing, it's increasing from 0 to 2. You got to look at that. That's 0. I know this. You think, well, that's -1, and that's +1, but you got to use the x's because you're looking at the graph from left to right. So it's increasing from 0 to 2. It's also increasing from 4 to 6, and it's also increasing from 8 to 10. That's where it's going up. That's where it's increasing. Okay, decreasing means where's it going down? Well, it's going down here, down there, downhill, just the downhill parts. So it's decreasing from 2 to 4. It's decreasing from 6 to 8. And it's decreasing from 10 to 11. All right, and that's where it's increasing and decreasing. And you could also use parentheses on those. Not as big a deal there because we're not trying to figure out if it's positive or negative. You know, it's the end of the decrease or the beginning of the decrease. So it's not quite as big a deal there. All right, next one, rate of change. Anytime you read the word rate of change, think back to Algebra 1 and think slope. All right, if you look at the first part here, it says where's the rate of change from? And it gives you this part. Where does from x between 0 and 2? So I'm finding 0 on the x, which is here. There's where that point is. And 2 on the x, which is there. And the graph is way up there. So I'm looking, where's the rate of change? Well, between 0 and 2, the graph actually went up from -1 to +1. So what we do is, to find it, I'm going to use little m. If you remember from Algebra 1, that's what slope was. And on your x's, you'd put y's on top, x's on the bottom. I had one kid tell me one time they remember that by saying the y's rise. The y's always rise. So from 0 to 2, the x is on the bottom. I'm going to do 2 minus 0. If you do 0 minus 2, you're still okay. But since I put 2 first on the bottom, I'm going to look at what the y value is at the 2. And I'll look right there, and it's a 1. So I'm going to put a 1 on the top minus -1 is 0. And I'm going to subtract those two. 1 minus -1, you do change, you get 2. 2 minus 0 is 2. And if you do that, you get 1. So that's the rate of change. The rate of change is 1. So as we went from 0 to 2, you know, the y was changing. Every one change in the x, the y also changed 1. Let's look at one more of those. It's a little bit tougher. Okay, 6 to 8. So from 6 to 8, obviously the graph's right there. It's going down this time. So I'm expecting my rate of change to be negative instead of positive. So let's see what happens here. Again, when you set these up, I'm going to go m, slope or rate of change. Remember, slope and rate of change, same thing. I usually put the bigger number first. So I'm going to go 8 minus 6. Those are my x's. Now I need to find my y. Here's my 8 right here. My y right there is -1, so I'm going to put a -1 first because it goes with the 8. And look what goes with the 6. With the 6 is up here at +1, so I'm going to go -1. You always do subtraction. Rate of change, always subtract. On the top, -1 minus 1, if you do change there, you get -2. On the bottom, 8 minus 6 is +2. And if you divide that, you get -1. What I expected, I got a negative rate of change because it was going downhill. Going uphill, you're going to get positive. Going down here, you're going to get negative. I'm sitting here waving my hands like you can see that. Okay, 2 more slides here. How many x-intercepts are there? X-intercepts are the points where the graph crosses the y-axis. So it crosses right there, it crosses right there, it crosses right there, there, and there. So if I count, I said how many? 1, 2, 3, 4. That's 6. There are 6 x-intercepts in the graph. Now, the second part says identify zeros. If you can get this today, it'll help you so much. Zeros and x-intercepts are the same thing. Zeros are where your graph crosses the x-axis. Zeros are x-intercepts. So it says identify them. Where are the zeros? Well, there's a 0 at 1. There's a 0 at 3. There's a 0 at 5. There's a 0 at 7 and 9 and 11. Those are your zeros. Now, notice I use the x coordinates again. Almost everything we've done today, we use the x values, not the y. The only thing we use the y for is when we did rate of change, and we talked about how you find rate of change. So put the y's on the top. Other than that, everything's been x's. Last thing here. Directions say the table below shows some values of a function. On which intervals is the function's rate of change positive? Select all that apply. So the first one says between 0 and 1. So I'm going to look between 0 and 1. That's here to here. 0 to 1, look what happens with the y. It goes up. It goes from 50 to 75. So that would be a positive. It definitely is a positive rate of change. Let's change colors here. The second one says from 0 to 3. 0 to 3 goes all the way from there to there. Look what happens to the y. It goes from 50 to 65. So that's a positive rate of change because it's going up. Let's look at one more here. Let me see if I can find another that goes go red. The last one says from 1 to 3. From 1 to 3, look what happens with my y. It goes from 75 to 65, which means it's going down, which means it's a negative rate of change. And let me show you this one more time before this video ends. If you wanted to find out exactly what the rate of change was, let's do this last one. You do your x minus x on the top. Sorry, just told you wrong. That on the bottom. Golly, x minus x on the bottom, and on the top, put your y's. The y that goes with the 3 is a 65. The y that goes with the 1 is a 75. If you subtract the top, you get -10. If you subtract the bottom, you get 2. -5. We knew it was negative already, and this is -5, rate of change. All right, there's one thing I have to teach you tomorrow in class. It is just too crazy for the video. It's all calculator stuff, so I will show you that in class tomorrow when you come in, and I will see you then.